So I'm going to do a little bit of review for the test today, and I'm also going to take questions off top 20, but here is f of x. Everybody write this down, please, on a blank notability doc. X squared plus 7. That seems pretty tame, but what the heck is this comma? X is less than or equal to 2. What is that? It's a domain. Good. And then here's g of x. It's a different function. And it's the square root of x minus 7. And it doesn't have a domain. Or does it?
It does.
It does. It has an implied domain. You should figure that out and put it here. All right? Now, I'm not going to do all of these things, but I want you to think through, and if you don't know how, you should ask me. I know how to find the x-intercept of them. Think it through. X-intercept is where what? Y equals 0. So you'd set their f of x, the y part, equal to 0, and you'd solve. How about the y-intercept? That's where what? X equals 0. I would also be able to find f with a little negative 1. What the heck does that mean? Inverse of it. And I would also know what the domain and range of both of these things are. So we already have domains listed, but what the heck is the range of both of them? Do you know? I know. Let's talk about the range for just a second. What's the range of this? Well, I don't have a way of getting the range. Get a sketch of it in your head. Everybody right now sketch x squared plus 7. And when you see the sketch, the range will become obvious. Saloni, I think you were saying it, but was it you? What is the right answer? Because it touches right there at 7. That's part of the range. This is at 0, 7. And the range is the y values, right? And so it goes from 7 to infinity. Why would you ever need the range? Well, because in this unit, we do talk a lot about the domain and range switching around. Why? On inverses, the domain and the range swap. Okay, so do you know the domain of this one? Yeah, because it says it only works when x is less than 2. Well, technically, then I'd have to erase part of this because it only works when x is less than or equal to 2. I'm being pretty fancy here, but it starts at 2 because of that. All right, now I know the domain and range of that. Can you tell me the domain and range of f negative 1? What? That's the inverse. So this domain just becomes the range. And it would be x is less than or equal to 2. And this range, which we just said a second ago was from 7 to infinity, was the range. Remember that? That was the range. That range becomes the domain. 7 to infinity. You don't really have to think too much. You just have to be able to know that the domain and range from that graph can be switched around so that the inverse has the range becomes the domain and the domain becomes the range. All right, and you can't trust. When you find an inverse and you look at it, you'll think it's one thing. Don't let that mislead you. Always take the original function and its domain and range and flip them around. That's the way you get the answer. So even if you were to find the inverse of this and it has x squared plus 7, because it does, I'll save you some time. The inverse of this one would end up coming out to y equals x squared plus 7. You would think that its domain should be all reals, because I'd look at that and go, the domain's all reals. But it's not, because the range of this one wasn't all reals. So you have to find the domain and range of the original. All right, so let's do that. Everybody right now, you already probably found this domain by setting x minus 7 greater or equal to 0. X greater than or equal to 7. How many of you knew that x was greater than or equal to 7? Raise your hand if you had that one right. Good. That's the easy part. What's the range of it? Draw a picture. Remember? You should be able to draw a picture of square root of x minus 7. You're like, I don't know what the square root of x looks like. Looks like this. And then what if you do minus 7 to it? You should know where to move it. And then you'll be able to tell the domain and range of it. Take a second. Find the domain and range of the g function. I sketched the parent. I did not sketch square root of x minus 7. When I said minus 7, did you know it would move to the right 7? So this is at 7 comma 0. Did you know that the domain of this thing would be from 7 to infinity? And did you know that the range of this thing would be from 0 to infinity? Ponder that for a moment. Does that make sense to you? Okay, then g's inverse. Don't even think about what it looks like. Domain and range. Well, this domain becomes that range. 7 to infinity. Don't even really have to think. Just have to know a property of inverses. And the range becomes the domain. 0 to infinity. Done. Okay. Now what else do we have to be able to do? We have to prove two things are inverses. I think that this and this, the two functions I gave you, I think that those are inverses. Prove that they either are or that they aren't. I'll pause for a second while you try proving that. And then I'm going to open it up to questions. You might have questions about certain things from this unit. Or you might have top 20 questions, which you can look up at Algebra Ninja. All right, so these are not inverses. Can you see just something right away when you look at them?
Yeah.
I bet you didn't notice it right at first, but one of these would need to be plus to be really inverses of each other. And if you look at the original, one of them was a plus. So, but didn't we do this once too on a worksheet where you had to like prove they were inverses and then they weren't? Yeah, it was the very first question. So if I make this a plus, it would have been inverses. Moral of the story, we aren't promising whether they're going to be inverses or not inverses, but you need to know the process. F of g of x equals g of f of x. And if you do it right, they'll equal x. And I bet some of you didn't notice until you were, and that's logical. I didn't notice that I had written them down differently than I was expecting to write them. But you would notice at this point when all of a sudden the f function is eating the g function and something isn't canceling. And then I go plus 7. And once I square that square root, I get x minus 7. And since there's a plus now they'll cancel. But when that was a minus before, they wouldn't have canceled. But now that I made it a plus, they would cancel. And yay, it's just x. And you'd have to do both sides. Remember, proving one side doesn't prove the whole thing. You got to do it both ways. So I'm going to do g of x now, and that's square root of x minus 7. But I put in place of the x, I put the x squared plus 7. And now with this change to a plus, of course, it's just the square root of x squared. X equals x, yay. Moving on. Is there any other topic now that you want to bring up? Like, I'm afraid there's going to be one of these on the test, and I'm wanting to practice it. Yes?
Would you problem off of the report sheet?
Sure, read it.
So, let's do x squared plus 16x minus 5.
K of x equals, one more time.
X squared plus 16x minus 5.
Excellent, now what?
And then find k inverse.
Okay, find the inverse of k. So first of all, would you agree this is like y? Second of all, would you agree that x and y need to switch? Next, if I'm going to try to get this thing solved for y, I need to get the y's alone. So I'm going to add 5 to both sides. Now, This is gross. It is not easy to solve this thing for y at this point. This is one where this is beyond the scope of our test. But if you had to solve it, I'd be thinking about the answer has to have x's in it. I can't just factor it, even though I'm so tempted to, because I can see it factors. But if you factor something like this, and then it's not set equal to 0, then I'm not going to be able to get y alone. So that doesn't do it. So bottom line, we wouldn't make you do one that's this hard. But if you want to practice one that is hard but not this hard, here's one that we would expect you to do that's like that. Y equals 2x over, you don't have to know, it would take too long, x minus 4. And if you ever want to know on something like that, go to Wolfram Alpha. It can solve anything. Wolfram Alpha. It's like the Google for math. Probably shouldn't have told you that because you could use it to cheat, but you're not going to be able to have access to it during a test. So anyway, this is the hard kind where it is hard enough that we could test on it, and it's not too hard so we could test on it. All right, what if you had to solve this for x? Well, normally what we do is we swap x and y, so I'll do that. I'll do this quick. I'll make this an x, this a y, and this a y. Then you're solving for y like normal. We have practiced it, but Saloni, since you asked about one of those weird solving ones, let's solve this one instead, because it's hard, but actually something we would test you on.
It was on the river.
I understand. I get it. It's a fair question. I'm just trying to guide you towards, let's not spend 20 minutes on something you don't have to do. There is a key, by the way, which either A, the teacher messed up on the answer, or B, they've got the answer for you there. Was the key posted? I think it was posted. Okay. All right, so this is the more like hard but doable kind. I hope you figured out that we have to clear the fraction. So we're timesing by the denominator. Then I'm going to multiply this out. xy minus 4x equals 2y. Next, I'm going to try to get the y's all on one side. You couldn't do it the slow way or the fast way. The fast way is subtract xy. Because then all the y's have gotten to the same side right away. And I'm going to take out the y right away. And I get 2 minus x. I skipped a step. If that annoys you too much, this was 2y minus xy. And then I made it into that. Then I'm dividing both sides by 2 minus x. I don't call this the careful test. The careful test is where you gotta go f of x plus h minus f of x all over h. We've practiced those a lot of times. There's hopefully something like that on your review. Was there one like that on your review? Okay, good. All right. How many of you were able to pull off negative 4x over 2 minus x? Not too many of you. Then that means either A, I made a mistake, or B, you guys had trouble with that. If you want another practice on that, I can help. But look at it, see if you think I made a mistake or if you made a mistake. Now, one more thing. Because of how there was 2 ways you could do this, some kids will have done it a different way that ends up multiplying by a negative 1 on the top and the bottom. So just so you know, this could have been 4x over negative 2 plus x, aka x minus 2. That's the same thing. That's the same as this. Do you get, you can multiply by a negative on the top and the bottom because that's the same as multiplying by 1. So you can do that. So this answer was just as good as this. Okay. I'm ready for the test. You guys aren't asking many questions, which is fine. But if you have more questions, I can do more. Jada.
Is there going to be any of that, like, where it gives you...
Don't ask that kind of question. Ask me a question about doing a problem. I don't like to have you ask, is this on the test, is that on the test?
When you do a problem because it doesn't come up in a while, where it's like, it gives you an already made composition, you have to decompose it sort of.
Oh, decomposition. Yes, I like it. All right, so here's one. Let's say we had f of g of x came out to an answer of 1 over the square root of x minus 3 plus 7 on the outside of the square root, but on the bottom. And let's say that's the composition. What could g of x have been? The thing that got eaten. And then what would f of x have had to have been? The exception to, like me telling you what's on or not on the test is if you ask me a question that is just too hard for the test, I will tell you that. This is not too hard for the test.
But there's a lot of different ways you can answer each one.
Yes, there is multiple ways you could get the answer. If we were to give you a question like this, we would not make you think of every way you could have done it. We would just ask for one way. All right, so you could have said x minus 3 was the thing that got eaten. Or you could have said the square root of x minus 3 is what got eaten. Or you could have said the square root of x minus 3 plus 7 was the thing that got eaten. And if all of that got eaten, it got eaten by a 1 over x function. That's one way. Another way is where just the x minus 3 got eaten. And then it got eaten by a 1 over square root of x plus 7, correct. And then there was that middle way too. So that's called decomposition. Good question. Is there any other topic that you would like to review? All right, then I'd like to move into a little bit of top 20 review with the ones that kids get wrong the most. Sadly, right here, most people want to multiply that all the way out and go x minus 3 times x minus 3 and multiply that all the way out and then subtract 7 so the whole thing equals 0, and then they look and then it can't factor. And then if it can't factor, then they got to use a quadratic formula which has 16 parts. What I'm trying to say is that's a really slow way. The really fast way, how would you start? Sloan. Square root of both sides. Everybody try to take it from there. Stella, what do you think happens on the left side?
It just goes to x minus 3.
Oh, you're so close, but you've forgotten something important.
And then there's the plus and minus.
Yes, it's absolute value of that. I don't want you to think, see, this can't magically turn into two things, plus root 7 and minus root 7. That just can't happen. But this can split into two equations. X minus 3 is square root of 7, and x minus 3 is the negative of the square root of 7. And from there, you should be able to solve it. Just a reminder, if you're doing the top 20 over today, you would have to say SQRT7, and it'll say right in the hint, like, hint, right answer like this. And I think it has a parenthesis around it. And then if I'm adding 3 to both sides, you'd have plus 3. Plus 3, plus 3, and that would be negative SQRT7 plus 3. Yes?
There would be a plus or minus on the top 20.
Left hand and
That it's given in the problem where if there's a plus and minus, the plus and minus is already in the answers, and you just put out what's on both sides of it. You know what I mean? Because there is no plus minus key, so we ask what's in front of the plus minus, what's after the plus minus. Okay. Any other top 20 skill? Here's the one that gets missed the most. I'll just do one of those. I asked last hour, and I had 3 ways to start this problem. And there's really only one good way to start this problem. Who wants to tell me? Sylvia.
you get rid of the fractions.
Get rid of the fractions, yes. So we're going to times everything by what?
The denominator.
Yes, I'm going to use a 3, but then tell me, That is an okay way to start it, but there's a faster way. Yes, but I'm going to break it into 3 times 5, because if you can factor the 15, you should. Watch why. If I'd have written a 15, now I'd have to figure out how to reduce those. But if I write it as 5 times 3, cancel, 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 cancel. And then this is just 10n plus 3 equals 30, and isn't it easy from there? See how just one thing we multiplied by, granted it was kind of 2 things at once, but instead of 15, choosing 5 times 3, smart. All right. Now, why is this important? Because we have problems just like this on your next test where you have to clear the fractions out. We just did one a second ago where there was like y plus 2 in the denominator. You got to know to multiply by the denominators. So these top 20 things are critical, every one of them. If you're getting one wrong, it's because you don't know a basic, which is going to bite you on a next major test. If I can get these fixed early, if we can get all you guys up to like 18 out of 20, then that means you won't make those algebra mistakes and you will be super glad you got that fixed. Same thing in calc. Kids have the same weakness. If I can get you fixed now, this year, to where you don't have those weaknesses, this whole rest of this year is going to be so much easier. Not saying easy, but easier. And next year, it'll save you an AP Calc too. All right, I think it's time. So this is the part where either A, you already have an awesome top 20 and you don't have to do it because you can just work on the worksheet instead or other things. Or B, your top 20 is nah, but you want to retake it. Maybe you got a 15, but you want to retake it. Cool. But if you have a 13 or lower, you need to retake it. I have conferences coming, and I really would rather not talk about how you have super low basics. It's not fun for me or for your parents, and then they go talk to you, and then it's not fun for you. It's like a lose-lose-lose. So let's try to fix those. All right, that's all I got for the video for today. The rest of the hour is just them working on the review worksheet, and the test is tomorrow.